All right, good morning. I'm Leah Applegarth, and this is Precalculus, section 2.1, and this section is called functions. So if you need to pause this recording to populate your notes, go ahead and do so now. We are going to determine whether a relationship represents a function. A relation is a correspondence between two sets. Make sure you put this learning objective in your notes. Write this down. This is the topic of our discussion for the next couple of minutes. If x and y are two elements in these sets, and if a relation exists between x and y, then we say that x corresponds to y, or that y depends on x, and we write x implies y. So a relation is a correspondence between two sets. So maps and ordered pairs as relations. We have number of representatives listed in our output column and our states in our input column. Alaska has 7 representatives. Arizona has 8 representatives. California has 53. Colorado also has 7, like Alaska. Florida has 25, and North Dakota has 1. So when you map it, you list your inputs on the left and you list your outputs on the right, and then you just arrow to the corresponding item. If we are a function can have an input and a corresponding output. All right, so let's look at the true definition of a function. Let x and y be two non-empty sets, and that means they have actually items in them. A function from x into y is a relation that associates each element of x with each element of x exactly one element of y. So a function has from x with each element of x exactly one element of y. So I can have, and I think of it like this, a quadratic function, which is usually a u shape, a y equals x squared, is a function because you can have an x value like 2, when you square it, maps you to 4. And if I go negative 2, also maps you to 4. What you can't have is if I plug in 6 and I get out 2, and then I plug in 6 and then the next time I get out 7. That situation is not a function. So let's do a couple example problems where we determine whether a relation is a function. So we're comparing the level of education and the unemployment rate. And if we look, each element here maps only to one item in our output. So if we want to say which function it is, we say, yes, it is a function. The domain is no high school diploma, some college, and college graduate. And the range is these 4 numbers. All right, so here's the number of calories is our input or our domain, and the total number of fat is the range. So this one maps to just 1. The Big Bacon Classic maps to just 1. The Whopper is just 1. Chicken sandwich goes to 23. McDonald's Big Mac goes to 33, and McChicken goes to 23. And if we look, this is a function. The domain is these values, 410, 430, 540, 580, 600, and 750. And the range are these numbers, 23, 24, 19, 23, 24, 29, and 33. Make sure when you list them, the domain and range, that you are listing them in order from least to greatest. All right, let's look at this scenario. And we have carrots. I'm going to say that this is probably our diamonds. We'll say diamonds just for fun. And that this is the price for those diamonds. And I can tell right away that this is not a function because of this value here. A 0.86 carat diamond on this hand costs $33,329. And on this hand it costs $3,097. Because I have two different outputs for this one input is not a function. All right, I actually want you guys to write this down. These are the ones I want you to write down. So we're going to determine whether each relation represents a function. If it is a function, state the domain and range. So we look at this. I look at all my inputs. 2, my output is 3. Inputs 4, outputs 1. Inputs 3, output -2. Input 2 and output is -1. This is not a function because I have this input of 2. That gives me 3, and 2 right here gives me -1. So because I have two different outputs, for 2, it is not a function. So I look here, -2 gives me 3, 4 gives me 1, 3 gives me -2, and +2 gives me -1. We can say, yes, this is a function because no ordered pairs have the same first element and different second elements. Let's look here. 4 gives me 3, 3 gives me 3. Now it's okay to have an output give me, or an input give me the same output like in these two ordered pairs, but I can't have 4 give me -3 because here it's giving me 3. So I can't input 4 and get out -3 and input 4 and get out +3. So this is not a function. All right, we're going to now determine, I want you guys to write this down, we're going to determine if the equation y equals -1/2 x minus 3 defines y as a function of x. So yes, this is a function, since for any input x, when you multiply -1/2 and then subtract 3, you would only get one output y. This is a line, and there is no way you can input a value for x and get out a different value for y than when you previously inputted that number. So if I plug in 1 for x, I will always get out -3.5. I can't put in 1 for x and get out anything different than that. So this is a function. Okay, write this down. This is a situation. This is an equation. X equals y squared plus 1. So the first thing we want to do is solve for y. And we do that by subtracting 1 from both sides. And then taking the square root. When we take the square root, we have to account for the positive and the negative answer that could come out from squaring. So because I have a positive answer and a negative answer for the same x value, this is not a function. If I plugged in 2, 2 minus 1 is 1, square root of 1 is 1, and then I would have to go, the answer is +1 and -1. So for the input of 2, my output is +1 and -1, so definitely not a function. All right, write this learning objective down. We are going to find the values of a function. So to find the value of a function, we input our input number into our function and get our output. So this is a test of your bookkeeping skills. Can you keep track and apply the correct applications to these functions? So a function machine, so I want you to think about your function as a machine. We put something into our function machine, our function operates on that value, and then it gives us an output. So we have been calling it x and y, and now that we're talking functions, we're going to talk about it as x and f of x. So where we had y before, we are now going to use f of x, or a function in terms of x. So it only accepts numbers from the domain of the function. If it's outside the domain, we cannot put it into our function machine. And for each input, there is exactly one output, which may be repeated for different inputs. All right, so when we want to find the value of a function, so go ahead and write this down. It's going to be helpful to have this example in your notes since there is a quiz question just like this. So for the first one, here's our function, f of x equals negative 3x squared plus 2x. We are going to take out x for a, for this first problem, and put in 3. Now you have to remember your order of operations for this process, because I'm going to apply this exponent first. It's going to be 3 squared is 9. 9 times negative 3 is negative 27, plus 6 is negative 21. All right, so for the second one, we're going to take our f of x function. So we're going to take this whole thing, negative 3x squared plus 2x, and then we're going to take our function that we calculated here, plug the 3 in, and then add it to our original function. So that looks like this. So f of x is negative 3x squared plus 2x. And remember, we just did this operation here. This is negative 21. So my original function plus f of 3 is negative 3x squared plus 2x minus 21. All right, for c, I'm going to take my original function, this guy, and I'm going to multiply the entire thing by 3. When I do that, I distribute the 3 out and I get negative 9x squared plus 6x. For D, I'm going to do the same. We did this when we were testing for symmetry. So we're going to take out the x and we're going to replace it with negative x. And remember your order of operations, because I'm going to square this negative x to get x squared, and I'm going to multiply that by negative 3. That gives us negative 3x squared. And then I'm going to take 2 times negative x and get minus 2x. For e, I'm going to take my entire function, put parentheses around it, and put a negative in front of it. And then I'm going to distribute out the negative into my parentheses to get 3x squared minus 2x. For this for f, I'm going to replace x with 3x. So anywhere there's an x here, it's going to have parentheses, and inside of it, it's going to have 3x. Then I have to remember my order of operations. 3 gets squared, x gets squared, and it's 9x squared times negative 3 is negative 27x squared. 2 times 3x is 6x. All right, now for g, I'm going to replace x squared with x plus 3 and x with x plus 3. And this is the x plus 3 squared. If you remember, that is the same as x squared plus 6x plus 9. If you need to write this as x plus 3 times x plus 3 and FOIL it out, do what you have to do to get here. That is completely fine. So if you distribute out, you get 2x plus 6, and then I'm going to just have to distribute this negative 3 and combine like terms. So that would be negative 3x squared, negative 18x plus the 2x is negative 16x, and negative 3 times 9 is negative 27, plus 6 is negative 21. All right, last but not least, look at this crazy guy right here. We are going to take our entire function, replace it with x plus h, minus our original function, and then all divided by h. So here's our original function. We're replacing the x plus h. I'm then going to simplify this down. So I'm going to multiply out, distribute, and combine like terms. So this gets to be x squared plus 2xh plus h squared. That's what you get when you multiply x plus h times x plus h. And then the negative 3 is multiplied by that whole thing. I'm going to distribute out the 2 to get 2x plus 2h. And then it's minus, so I'm going to distribute out this negative to these guys. Minus a negative is plus. Minus a positive is minus. And now I'm going to distribute the 3, combine like terms, and then divide everything by h. So I get negative 3x squared, negative 6xh, negative 3h squared, plus this positive 2x and minus 2x cancel each other out to give you 0. 2h plus 3x squared. And then if you look, 3x squared and the minus 3x squared cancel out, leaving us with just negative 6xh minus 3h squared plus 2h. And if you factor out an h, and then divide by that h on the bottom, you get negative 6x minus 3h plus 2. Phew, that's a lot of math juggling there. Take a moment. Make sure you have all of your signs and your multiplications correct, and be okay with this. Is truly a test from top to bottom of your ability to deal with function values. All right, so if I'm using a calculator, it's really easy. You input your answer, or you input your x value, 1.234, and then you hit x squared, so find the x button on your calculator, and then square it, and it'll take the value that you entered and square it, and you go 1 over x, or square root of x, so it keeps referring back to the entered value. Graphing calculators can be used to evaluate any function that you wish. You can always put it into your y equals screen, and then if on your calculator you type y1, which is a key, if you use the your second function, and I'm looking at it on my calculator right now. All right, so I found my y1. Write this down. It's underneath vars, V-A-R-S, which is top right. And then I arrow to the right so that it's highlighting y, vars, V-A-R-S. And then I hit enter to ask for a function. And then I hit enter to ask for y1. Then I go parentheses, whatever my input is, and I picked 1. Close parenthesis and enter. Okay. So we are, if you're asking for an implicit form of a function, those guys look like this, implicit form. It's the form where you can plug it in, but you have to do some work to get the value of the other variable. An explicit form of a function is in the y equals or the f of x equals form. And when it's in the y equals form, it's called explicit. All right, here's our last learning objective. So to summarize, you can only have one output for the input. Two different inputs can share an output, but not vice versa. F is a symbol we use to denote function. A function has a domain and a range. And y equals f of x. If y equals f of x, then x is called the independent variable or argument of f, and y is called the dependent variable or the value of f at x. All right, so we're going to find the domain of a function defined by the equation. I want you to write these example problems down. So most notably, we're going to be finding domains that we know can't exist because of the math rules. Math rules say our denominator cannot equal 0. Math rules also say that we are not taking the square root of a negative number. That doesn't give us a real number output. So we look at our function and we say, what values make the denominator equal to 0? So we set our denominator equal to 0. And we can factor x squared minus 2x minus 3. And then so our denominator cannot equal 3 and negative 1. So our domain is all real numbers for x, except x cannot equal 3 and x cannot equal negative 1. If you look at B, B doesn't have any square roots and it doesn't have any denominators. So its domain is a set of all real numbers. C, we got some values underneath the square root. So we take whatever values we have underneath the square root and we say that has to be greater than or equal to 0. We then solve for x, so we minus 3 and divide by negative 2. Remember, when you divide by a negative number, the inequality switches. So this would be minus 3, so negative 2x greater than or equal to negative 3. Divide by negative 2, and you get 3 over 2, but x is going to be less than or equal to. So our domain is all x values less than or equal to 3/2. Or if you want to write it in interval notation, open parentheses to indicate that negative infinity is not included. So an open parenthesis means not included. A bracket means included. Since we can never get to negative infinity, anything involving infinity will always be an open bracket. Since 3/2 is included, it doesn't get to be a parenthesis, but it gets to be a bracket. All right. For finding the domain, so you start with a set of real numbers. If you have a denominator, exclude any numbers that give you a 0 denominator. And if you have a radical that's even, exclude any numbers that cause the expression inside the radical to be negative. All right, so here's an application. A rectangular garden has a perimeter of 100 feet. Express the area of the garden as a function of W and find the domain. So here's the area. This guy's W. So if the perimeter is 100 feet, so this guy plus this guy plus this guy plus this guy is 100, then W, which is the width, times the length, which is W minus 50, since 2 times the length plus 2 times the width is the perimeter 100. So if you divide that by 2, length plus width equals 50. So length is equal to W minus 50. So the area, or yeah, the length is equal to W minus 50. So our domain is any values between 0 and 50. Because if we put in any number bigger than 50, we won't have the area that we need. All right. So when we combine two functions together, instead of writing this long thing, we abbreviate it by saying our first function plus our second function, which are both functions of x. That's the same as adding the two functions together. Same with minusing. F minus g of x is the same as f of x minus g of x. Same thing with multiplying. F times g of x is f of x times g of x. And dividing, f divided by g of x is the same as f of x divided by g of x, as long as g of x is not equal to 0. So let me show you what that looks like. Add the two functions together, 2x squared plus 3 plus 4x cubed plus 1. Just add them all together. Simplify by combining like terms. Same with the minusing. Make sure you put parentheses around this g function so that you can distribute the negative and combine like terms correctly. Multiplying, you got to put parentheses around each function and then FOIL it out or multiply it through. Dividing, same thing. Whole, all of f divided by all of g. Make sure you take your time and simplify those functions. And have a great day.